So last time we met, we talked about a problem that looked like this, right? Most of the problems we talked about were a little bit more difficult than this. But this is a system, right? How do you know it's a system? There's more than one, right? And this particular system has two variables. And if we know we have two variables, what do we need? To solve it, what do we need? At least two equations, right? You remember that? Now, some people were confused about that before because I keep saying at least two equations. Can you have one equation if you have at least two? No, they were confusing that in their brain. Okay, so can you have three equations? 7? Right, we don't need that many. All we need is at least two. Okay, so in this particular equation, it already tells us x equals 4. And we take the 4 and we substitute it into the second equation and get 4 plus y equals negative 6. We subtract 4 from both sides and get y equals negative 10, right? We check to make sure that's right. 4 minus 10 equals negative 6. Well, that's true. 4 equals 4. Well, that's true. So that's the solution to our system, right? How do we write that answer? How? As an ordered pair, right? You remember that? Because we decided that was the point at which what happened? It's the point at which the two lines crossed. Okay? Now, I did give you some foreshadowing on Friday, and I said on Monday, what's gonna be true? What's gonna happen? You're gonna have 3 variables. And if there's 3 variables, what do you need? At least 3 equations. Very good correction. Okay, at least 3 equations. So let's get these 3 equations written down, and let's work on solving this system. Okay? Now, some of you are looking at me like, you are crazy, this is easy. And my response is, I know. I want to start out with an easy one though, so we can have some conversations first. Okay? So, what do you think we should do first? Huh?
Add the common terms.
Shouldn't we plug in what we know? I already know x equals 4. What if I go here? What would that tell me?
4 plus y.
Won't that tell me what y equals? Yes, right? So let's go ahead and do that. I'm going to rewrite the second equation, but instead of writing an x, I'm going to write a 4. So I'm going to write 4 plus y equals negative 6. Oh my gosh, this seems like exactly the same way we would have done it on Friday. Oh yeah, it is, right? Okay, so we subtract 4 from both sides, and we would say y equals negative 10. Well, if we know that x is 4, and we know that y is negative 10, what's this letter? Are you sure? How do you know it's not a 2? Because I crossed it, right? Okay? Now, sometimes I get super excited about math. You know that, right? And I get writing so fast. I'm like, 5x plus 2z plus equals 11. And I'm like, wait, what does that say? Is that 22? Or is that zz? Or is it z2? Or what is it? Okay? So I'm always going to put a cross through my z. Okay? I strongly encourage you to do the same. If you don't, okay. But if you mess up, shame, everybody knows your name. Alright? That's nothing. Okay? So I know x and I know y, and I want to find z. I can substitute what I know into the bottom equation, right? So I'm going to do that. I'm going to rewrite that bottom equation, but instead of writing x, I'm going to write a 4. And instead of writing a y, I'm going to write negative 10. Very good. Plus 2z equals 26. Well, 4 times 4 is 16. How do you want to look at this? Is this negative 3 times negative 10? Or is it 3 times negative 10? Okay, so if we do that, we get 30. So for the record, does it matter? If we would have done minus a negative 30, wouldn't that still be plus 30? Okay, good. All right, then plus 2z equals 26. 16 and 30 is 46. 46 plus 2z equals 26. You guys know how to do this, right? This is our super basic algebra. Subtracting 46 from both sides, 2z equals negative 20. And then when I divide both sides by 2, z is negative 10. So, how do I write my answer? You think so? So, like, 4, negative 10,
No.
negative 10?
Yeah,
Like that, Blaine?
I guess.
Commas in between.
You want commas in between?
With yeah.
Anything else?
Parentheses.
Oh, parentheses? Like that?
And label them with your words.
Oh, see, that would be a good thing if I had to, right? If there were other letters besides X and Y and Z, I'd want to label which one's which. But this is special. Well, what did we do when it was like that? What did we decide? It was what? X and Y, and it was the point of intersection, right? Guess what this is? The point of intersection. Ready? It's going to be twice in one day that I blow your mind. Are you ready? Here's the x-axis. Here's the y-axis. Here is the z-axis coming through the paper. Like this. You see it? Yes? So if I was going to graph this point right here, 4, negative 10, negative 10, I'd go 4 out, 10 down, and then what? 10 below the piece of paper. What? Okay, think about it like this. Let's see how good of an artist I am and how good of a visual observer you are. Can you see the 3 dimensions here? If this was my z-axis? See how this is going through the board or through the paper? So I could go 4 out, 10 down, and 10 back. Yes? See right here, this is a right angle. And right here, this is a right angle. And right here, that's a right angle. Isn't that crazy? Am I going to have you graph this? No way. No way. And so earlier somebody said, wait, so it's like 3 dimensions? I mean, who even does that? And I was like, you are a 3-dimensional person. You are. We are living in 3-dimensional space right now, are we? Can I draw it really easy on a 2-dimensional piece of paper? No, I can't. But the point I'm trying to make is that it's possible. And not only is it possible, that's what just happened. I took this line, because that's a line, right? And I took this line, because that's a line, right? And this, what's this? X, Y, and Z? That's not going to make a line, is it? What's the next up? Point, line, plane. This is an equation of a plane. And when I intersect a line and a plane, guess what I get? A point in 3-dimensional space. Okay? So if this was like R, S, and T, you're absolutely right. We need to label which one was which. Okay? So we would know for sure. So we don't just assume it's in alphabetical order, but we used X, Y, and Z, and we can know that that's in 3-dimensional space with the x-axis, the y-axis, and the z-axis. Okay? Any questions about that? So let's do one that wasn't quite as easy. Deal? Wait, does that mean it's automatically hard if I say it's not quite as easy? No. It takes a little bit more thought process. Okay? So let's do this one. Go ahead and write it down. I can promise you that the biggest mistake that people make on these problems, because I've already done it twice today, is they miss a negative sign. they write a negative sign where there's not one, or they forget to write a negative sign and write a positive instead of a negative. Be super careful about that. Yes, sir.
This would be like it's like problem one.
Huh? This is a different problem.
Was that like a 12?
What?
Yes.
That's 12x. Yes, sir. That's 12x. I don't know how to make it clear. I'm sorry, my 1 is longer than my 2.
Give it the little dash there.
Give it the dash thing?
Make it.
Like this?
Yeah, now it's a 1.
I thought it was a 1 before. Sorry. Okay. All right, you have it written down? I don't know if you guys know this. Let me show you something real fast. Look back here. If I say something like, do you have it written down? And you do, you can do this. You can like nod your head. That means yes. Or you could go like this. Like shaking your head. That typically means no. Can we work on that? Okay. Okay, so what do we have? Look at what we have. Our directions for these problems today are solved by substitution. Solve this 3x3 matrix with substitution. 3 variables, 3 equations. That's not why it's called 3x3, but we'll talk about that later. Okay? That's what we're going to mean for it now. For now, 3 variables, 3 equations. Okay? It's not really 3x3, but we'll talk about that later too. Okay? I have 1, 2, 3, 4, 5, 6, 7, 8 different variables to solve for, don't I? Because if I'm solving by substitution, what's the very first thing I do? I solve for one of my variables, right? Is there one of these variables that's easier than all the rest of them? Is there one variable that's easier than all the rest of the 8? Yes.
X plus Y.
Either the x or the y, right? There's 8 different variables here, even though there's only 3, the x, the y, and the z, but we're talking about each specific place, right? There's 8 places. Either the x or the y is easiest to solve for. Why? Why is that true? That's exactly right. There's no numbers beside them. There's no coefficients. That's the word you're looking for. Okay? There's no coefficients with the x and the y. So, I mean, could I solve for any of the 8? Yeah, but think about if I solve for this x. I would have to divide everything by 7. How would that look? It would look like a mess, right? I don't want to mess if I can deal with it. So if I'm going to choose one of the variables, I probably ought to choose either the x or y. Which one's right?
Either of them are right.
Either of them are right. So which one would you like to solve for? Y. All right? Why are we solving for y? Because he said we could solve for either one. We're solving for y because he said. All right? So if I'm solving for y, I'm going to subtract x from both sides. I'm going to get y equals negative 10 minus x. And because I know where we're going, I'm going to put that in a box because I'm going to need to find it later. Okay? So if I'm solving by substitution, the first step is to solve for one of the variables. Okay, done. Now what do I do with it? Plug it in where? So like right here? Yeah, that wouldn't work at all, would it? Because I would get exactly the same thing I've had before, except it would say negative 10 equals negative 10, which is true, but it doesn't help me out at all. I can't put it back into the same equation I started with. So I have to choose one of the other two. Which one would you like to choose? The middle one, okay? Why am I choosing the middle one? Because she said 7x, okay, I know what y is, so minus 5 times y, but again, I know what y is. It's negative 10 minus x minus 6z equals 200. Did I miss any signs? Did I get all my signs right? Okay, so now I need to simplify, right? I need to distribute that negative 5. So I get 7x plus 50 plus 5x minus 6z equals 200. How do you guys feel about me doing 2 steps at once? Are you okay with it? Okay, what 2 steps am I going to do at once? Okay, I'm going to combine my x's. And I want to do something with this too. What do I want to do with it? Good, subtract it from both sides. So what I end up with is 12x minus 6z equals 150. Okay so far? Alright. What does that do? What good does that do? All I did was get an equation with x and z in it. Do I know x or z that I can plug in right here? So if I have one equation with x and z, what do I need? Another equation with x and z. Yes. So I took what I knew was y, and I substituted into the middle equation because she said, and I got an equation with x and z. What do you think might happen if I take this, what I know for y, and plug it in the top? Do you think that would help us find another equation with x and z? Yes or no?
Yes.
Yes? Okay, so let's do it. 12x, oh you can't see, sorry about that. 12x plus 6 times y, which I know is negative 10 minus x, plus 7z equals negative 35. I'll scoot it up now. Did I get all my signs right? 12x, 6y, plus 7z equals negative 35. Okay. Distribute. 12x minus 60 minus 6x plus 7z equals negative 35. Once again, can I do 2 steps at one time? Okay, so I'm going to combine my like terms, and then I'm going to add 60 to both sides. So I get 6x plus 7z equals 25. So now what I have is I have 12x minus 6z equals 150, and I have 6x plus 7z equals 25. If I treat that as its own brand new system, is that something I know how to solve? Oh my gosh, it's almost like what we planned on Friday was going to be useful for today. That's because it is, right? Okay? So, if I'm looking at these 2 equations as a new system, how would you like to solve this system? Well, we know 3 ways, don't we? We know graphing, substitution, and elimination. That's exactly right. Okay? Would substitution be a wise choice here?
No.
Because why? None of the variables are alone, right? So, would graphing be a good choice here?
No.
Probably not, right? Because again, we'd have to solve for y. I mean, I guess we could graph on the x and z axis. We've already talked about that, right? But that would be kind of weird. So maybe elimination would be the best. What variable would you like to cancel out if we're doing elimination? X's? Okay. So what do I need in order to get opposite coefficients on the x's? Okay. So I'm going to rewrite the top one right here. So I have it in one place. And I'm going to multiply the bottom one by negative 2 and write that right over here. Is that okay with you? I mean, if it's not, I'm going to do it anyways, but whatever. Does that make sense? Yes or no?
Yes.
Okay. So I rewrote the top one. Got that right here. I multiplied the bottom one by negative 2 because I knew that multiplying the bottom one by negative 2 would give me the same number but opposite signs, so opposite numbers for the x's, which is what I need if I'm solving by elimination. Yes?
Okay.
Okay. Now what do I do? Combine them, right? 12x and a negative 12x.
Cancel it.
0. Negative 6z and negative 14z.
Negative 20z.
Negative 20z equals,
100.
very good, 100. Dividing both sides by negative 20. Z equals negative 5. God bless you. I finally have one answer. Right? So now I'm done, right? I can quit? Ugh. What do I have to do?
You have to.
Plug it into one equation.
Plug it into one of the equations. Which one?
This
Like
next one.
any equation on this page, I can choose, right?
No.
Yes. Is there one that's more intelligent to choose?
No.
There's two, actually, right? One of these. One of these two that I just messed with. Because if I plug in Z, what am I going to know? X. Okay. Which one would you choose? Top or bottom?
Bottom.
Why would you choose the bottom?
Because there's less variables. I mean,
The numbers are smaller. That's exactly why I would choose the bottom one. Okay? So 6x plus 7 times negative 5 equals 25. Well, 7 times negative 5 is? So 6x minus 35 equals 25. So if I add 35 to both sides, 6x equals 60. X equals 10. We're getting closer. I got 2 of them. How many am I finding? 3. So if I've got 2, where can I find the other one?
In the equation with the original true.
So one of the original ones, like up here?
The middle one.
I wouldn't, right? Where would I go?
The last one.
Right here. Because I already solved this one for y. Remember I told you we're going to put a box around it because we might need it later? Hey, it's later. Okay? So y equals negative 10 minus x, which was 10. What is negative 10 minus 10? Negative 20. Now I'm done? Ugh, seriously? What do I have left to do? Oh, I have to write my answer and I have to check it, right? What did I decide my answer was? 10, negative 20, negative 5. How are you knowing what order that goes in? Oh, alphabetical. Okay. All right. Just making sure. Okay. Now let's check it. We are going to use our brain, and we're going to use things that your teacher gives you to use. So turn your calculator on. Start a new page that's a calculator. And this is what I want you to press in. 12 times 10 plus 6 times negative 20 plus 7 times negative 5. Don't hit enter. What should it be? Negative 35. Hit enter. What'd you get? Oh my gosh, we're so smart. So it's the answer because it worked in the first one, right? That's what we got to make sure of? Oh, all of them? Oh, okay, good thing. Good thing I'm letting you use your calculator then, right? 7 times 10 minus 5 times negative 20 minus 6 times negative 5. What should it equal? 200. What does it equal? 200. Yes. All right. Last one. We don't even need to use our calculator, do we? X is 10. Y is negative 20. 10 minus 20 is negative 10. Oh my gosh. I know that's the answer for sure. I'm positive. Okay. Let's walk through the steps. Number 1. Solve for a variable. This is when we're solving by substitution. Fair enough? Solve for a variable. Substitute that variable into the other 2 equations. Right? Doesn't matter what order we do because we have to do them both. Because that gives me 2 equations with 2 variables that we treat like its own system. We solve that system, and it gives us one of the variables. I take that variable, plug it into one of these two equations, and that gives me another variable. I go back up to the beginning, somewhere up here. In our particular problem, this was the smartest place, right? Because we'd already solved for y. Substituted in there for the third variable. We write our answer, and then we check it. And then we know for sure that this answer is correct. Questions? Got this?